Hi and welcome into another LeetCode challenge. Today we'll be dealing with an easy one, first bad version. You are a product manager and currently leading a team to develop a new product. Unfortunately, the latest version of your product fails the quality check since each version is developed based on the previous version. All the versions after a bad version are also bad. Suppose you have n versions, 1 up to n, and you want to find out the first bad one, which will cause all the following ones to be bad. You are given an API bool is bad version, passing version, which returns whether version is bad. Implement a function to find the first bad version. You should minimize the number of calls to the API. So that generally makes sense. We see in the constraints that the number can get quite large. So let's think about it for a moment and get back to the solution. Alright, so we are back in the LeetCode console. I will be using JavaScript, but you can use many other languages as well. So the very basic idea which comes to mind would be just to create a for loop, go through each individual version, ask the API, and the first true would be the first bad version. But the issue is about number in the for loop and the number of these API calls. Because if we would have, let's say, had a 1 billion of such calls, then probably we would timed out. So the other approach would be a binary search, which we implemented in some other solutions. So let's think about this versioning. Let's say we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. And let's say the 8th one is a bad one. So in normal for loop, we would get our O of n, and we need to go through each individual element and hit this one, so the second before last. But when we will do a binary search and instantiate a marker on the beginning and on the end, we can always aim in the middle. Because if we will aim in the middle and we will know that the middle value is a good value, then we know right away that we can remove from our equation and calculation everything which is on the left and just try to shrink this border and number of elements in each iteration. So to do that, let's instantiate we will declare a left marker, which will be always a version 1, and we will declare a right marker, which will be always n, so the last version. And then iteration will be in a while loop. We will do this while loop till the markers don't cross. So we will do it this way, and here we will always calculate the middle elements. So we will do const mid, which will equal to left plus right minus left divided by 2, and then we will do matfloor out of it for it to work properly. And now we will do our API call. So if is bad version, I think that this was it called? Yeah, is bad version, we will pass here the mid, and if it is bad version, we need to check the left side, and we know that we have a border on our right side. So we will do that. The right side is our current mid. We are doing it for the mid because we know that it's already the bad version, and actually this can be the answer, but on this moment we don't know it yet. And if it's not a bad version, then we know that everything on the left can go away. So we will move the marker for mid plus 1, and here we are moving for mid plus 1 because we already checked the mid and we know that it's a good one. So the first bad version can be the second element. And at the end of this loop, we will just return left, which will be our answer. So let's run it. Okay, we have both cases accepted, and let's run the whole suite. And yeah, we are accepted on everything. So that's my take on that. Hope you learned something, and see ya in another one.